What's up, guys? So today we are going to be doing an example limits problem where we're dealing with a rational function that includes a square root. For this one, we're doing the limit as x approaches 3 of the square root of x plus 6 minus 3 divided by x minus 3. The first step of these problems should always be trying to plug in the value that x is approaching into your function. Because if we just get a real number solution, then we're done. Now if I do that, I'm going to get the square root of 3 plus 6 minus 3 divided by 3 minus 3. That's going to give me square root of 9 minus 3 over 3 minus 3. And we know that the square root of 9 is 3, so this eventually gives us 0 over 0. Now 0 over 0 is undefined, and that means we need to do a little bit more work to solve this problem. Now if it was a polynomial, our game plan would always try to be factor out the top and the bottom and cancel out whatever factor is causing both of those to go to 0. But in this case, we don't really have any polynomials. We're dealing with like a square root function. And so it's not as obvious, I guess, the steps to take in order to factor out our numerator. What we need to do to simplify this is recall the difference of squares rule, which basically says that if you've got two terms called a minus b and a plus b, so our two terms being a and b, and we've got two binomials, one where you're subtracting them and one where you're adding them, they will always FOIL into a squared minus b squared. This doesn't look that helpful right off the bat, but let's say we had something like, I don't know, the square root of x minus 2 times the square root of x plus 2. Using the difference of squares rule, we would automatically know that our first term is going to be the square root of x squared, which is just x, minus the square root of 2. Or I shouldn't say the square root of 2, minus 2 squared, which is 4. And that's a lot nicer than dealing with square roots. If we apply that rule to our numerator, if we consider our square root of x plus 6 as our a term and our 3 as our b term, we can set up a rule like square root of x plus 6 minus 3 times the square root of x plus 6 plus 3. And using the difference of squares law, we know that that's going to FOIL into the square root of x plus 6 squared, which is just x plus 6, minus 3 squared, which is minus 9. And that's a lot nicer than what we have going on in our numerator right now because we don't have any square roots there. All right, so if we want to get it into that form, well, that means that we're going to need to multiply our numerator by this term. But the problem is you can't just multiply something into a function, right? Because you'll be changing the function. So what we do instead is we multiply it on both the numerator and the denominator. And the reason you're allowed to do this is because if I multiply this on the numerator and the denominator of a function, they'll both cancel out, and essentially I'll just be multiplying by 1. And that doesn't change the function. So I'm going to rewrite this limit, and I'm going to say we're going to be solving the limit as x approaches 3 of the square root of x plus 6 minus 3 divided by x minus 3. I'm going to multiply this term on both the numerator and the denominator. Now this term is called the conjugate. If you're working with a minus b, the associated a plus b would be the conjugate. And if you're working with a plus b, the associated a minus b would be the conjugate. So I'm going to multiply this by the square root of x plus 6 plus 3 divided by the square root of x plus 6 plus 3. Right? And we can kind of see that both of these terms would just cancel out and go to 1, which is why we're allowed to do this, and we're not changing the function at all. All right. Simplifying our numerator is very easy. We just multiply both numerators together, and we already know what that's going to be because we've done that here. And so we know the numerator is going to simplify to x plus 6 minus 9. And for the denominator, I actually recommend just leaving this alone and kind of separately factored. So we're just going to leave the x minus 3 that we had before by itself, and the square root of x plus 6 plus 3 by itself as well. All right, so now on our numerator, we can simplify this a little bit. This is going to turn into the limit as x goes to 3 of x. 6 minus 9 is minus 3, so we just have x minus 3. Divided by the exact same denominator as in our last step. All right, so from here, the nice thing that happens is, well, we notice we've got an x minus 3 on our numerator and an x minus 3 on our denominator. And what that allows us to do is just cancel those out. So if I cancel them out, I now end up with the limit as x goes to 3 of 1 over the conjugate term that we multiplied on earlier. All right, so now we're left with a new rational function that still has a square root, so it doesn't really seem like we've simplified this all too much or made it any easier. But the cool thing is, if we substitute our 3 in for x now, we'll end up with 1 over the square root of 3 plus 6 plus 3. So that's the same as the square root of 9, plus 3. And that's just 1 over 6.